In this video I'm looking at the solution to question 3 of the June 2010 Edexcel D1 paper, and the topic of the question is algorithms. In the question we're told that we have a list representing the weights in kilograms of 7 statues, and they are to be transported in crates that will hold a maximum weight of 60 kilograms. In the first part of the question we're asked to calculate a lower bound for the number of crates that will be needed to transport the statues, and then to use the first fit bin packing algorithm to allocate the statues to the crates. Having used the first fit bin packing algorithm, we then go on in part C to use a full bin algorithm, and finally in part D to explain why it's not possible to transport the crates using fewer crates than the number needed for that part of the question. Well, in part A of the question then, if we look at the total weight of all these statues, it turns out to be 239. So that's the total weight. And therefore we need a minimum of 239 divided by 60, which is 3.98. So therefore, to the next whole number, 4 crates are needed, and that's a least or a lower bound. In part B, the first fit bin packing algorithm. So that means we put the numbers in order into a bin which will the first bin which will accommodate them. So taking these one at a time, again you don't have to actually draw anything, but sometimes it's helpful just to keep a rough track of roughly what we've got. So in the first bin we're putting in 41, and then because we've got a maximum here of 60, then obviously the next one of 28 won't fit in that bin, so therefore it goes into a second bin, requires the 28, and likewise 42 won't fit into either of the first two, so we need another one for that, so 42 comes into here. Then the 31, well 31 won't fit into the first bin, so this is bin number 1, but it will actually go into bin number 2, and 31 giving us then a total of 59, so just a gap at the top there of only 1. 36 won't fit into any of these first 3, so we need another bin for that. So 36 coming in just over halfway. And then 32, again likewise won't fit into any of these. And although one would have hoped that the next one would, again it won't, it's too large. 29 goes over our total, so we need a 6th bin with 29 in it to get our statues crated up. So the marking for these two parts of the question, in the first part there was simply an M1A1 mark, and in the second part there was M1 A1 for getting the first 4 bins correct, and then A1 for getting the total there. So we ended up with 6 bins in total, even though we were hoping that 4 might be possible. The next part of the question then goes on and uses a different algorithm. This time it says use the full bin algorithm. Now full bin just means putting together numbers which we can to make up our values of 60 if we can. If we put those together, well, there are different ways of doing this, but one would be to say that in one first bin we can have 31 and 29 making up 60, and there's another full bin of 42 and 20 sorry, I meant 32 and 28. And then we're left with the others, 42, 41 and 36 going into separate bins. So 42, 41 and finally a fifth bin, size 36. So there are 5 bins required. So it says, explain why it is not possible to transport the statues using fewer crates than the number needed. Well, if we look at the numbers, there are 5 of the statues with weights which are greater than 30. So each of those is going to take up at least half of our crate, and therefore we need at least 5 crates needed. The marking for this question, then, there were these parts of the questions rather, there were 2 marks, a method mark and an answer mark, and 2 B marks in the last part of the question. Well, that's the solution to this particular question. You'll find solutions to other questions at www.furthermaths.org.uk.